The autonomic nervous system is a motor system that innervates cardiac muscle, smooth muscle, and glands. So the ANS, or autonomic nervous system, innervates cardiac muscle, smooth muscle, and glands. It has two arms to it, two parts. And the first one is the sympathetic system. And the second one is the parasympathetic system. So I'm going to compare these, show how they're structured, and compare them to the somatic system. So if we have a nervous system, so let's just say that's the brain, and here's the spinal cord. Diagrammatic, use your imagination. So the CNS, brain and spinal cord. So in the somatic system, we know that the neurons that go to skeletal muscle start in the anterior horn of the spinal cord. So they exit here as one neuron and they go to whatever skeletal muscle. So skeletal. This is somatic motor. And of course, it is conscious, it is voluntary. So we also know that this area here, from neuron to the muscle, is called the neuromuscular junction. And it is connected, or it innervates the muscle through sending a neurotransmitter called, so a neurotransmitter here, called acetylcholine. Okay, so this is review. We already know this. So the autonomic nervous system, those neurons also start in the spinal cord. So we have sympathetic and parasympathetic. So the neurons are a little bit different in that there's not one neuron that goes to the effector. It's going to be a pathway of two neurons. So there's going to be a neuron, and then that will synapse to another neuron to go over to the effector, which of course in the ANS is, again, cardiac muscle, smooth muscle, and glands. In both systems, it works that way. They do look a little different, or I'm drawing them different specifically. There's a reason for the way I'm drawing it, okay? So right here, right in this area, on both, where the synapse occurs between the first and the second neuron, is a ganglia. So there's going to be more than one neuron there that is synapsing. So this ganglia here is the section, or the ganglia area that connects these two neurons together, right? So this first neuron on this side is called the preganglionic neuron. So this is also the preganglionic neuron. This one up here is sympathetic. This one down here is parasympathetic. Okay, so on this side, this is the postganglionic neuron. Over here it's the same, postganglionic neuron. Okay. In the sympathetic nervous system, I have specifically drawn the preganglionic neuron short because the preganglionic neurons in the sympathetic system are short. The postganglionic neurons in the sympathetic system are long. In the parasympathetic, it is reversed. The preganglionic neuron in the parasympathetic system is long. In the postganglionic system, it is short. Okay? So, also, in the system, the preganglionic neuron is myelinated. It's lightly myelinated, but it is myelinated. So all the preganglionic fibers in the autonomic nervous system are myelinated. But the postganglionic neurons are not myelinated. Okay, so myelinated. Okay, so these two systems, or these two neurons within these two systems, are linked together. They are synapses. And the synapses, of course, are connected or speak to each other through neurotransmitters. At the ganglia between the preganglionic neuron and the postganglionic neuron, the neurotransmitter here is acetylcholine. This is also between preganglionic and postganglionic. It is also going to be acetylcholine. Okay. In the parasympathetic, where the effector and the postganglionic neuron synapse together, the neurotransmitter is also going to be acetylcholine. Okay, but the sympathetic nervous system does not use acetylcholine at its postganglionic synapse with the effector. It uses let's do a light color. Okay, so it uses a different neurotransmitter, and it is called norepinephrine. And that is not very dark. Let's make this a little bit darker. Norepinephrine. Okay, so Ne is norepinephrine. Could also be epinephrine. Okay, so that is the difference there between those two. Now, at the effector, so this is organs here. At the effector, the effects of the neurotransmitter can be, well, if we back up, at the ganglia, where acetylcholine is the neurotransmitter between the pre and the post, it's always going to be stimulatory. It's always stimulatory. Okay. Same at the neuromuscular junction. Acetylcholine, always stimulatory. If your muscle is stimulated at the neuromuscular junction, it's going to contract. Okay. If presynaptic neuron sends acetylcholine to the postsynaptic neuron, there's going to be an action potential going down the post. Okay. But at the effector, it's not that way. It can, the norepinephrine or epinephrine or the acetylcholine in the parasympathetic can either be stimulatory or inhibitory. So it depends on the receptor. So in the parasympathetics, acetylcholine to the heart is going to be inhibitory. Even though acetylcholine is stimulatory over here at skeletal muscle, it is inhibitory at cardiac muscle. It slows heart rate. Okay. So these neurons are just that. They are neurons, and they go specifically to specific organs. The neurons, it's going to go to the heart, it's going to go to the pancreas, it's going to go to an organ in the digestive tract, whatever, but it's going to go to a specific organ. In the sympathetic system, there is something else that can happen. And in the sympathetic system, there is a preganglionic neuron that goes to an actual organ. And that organ, that's not a very good picture, but that organ, make that look a little bit better. So that organ is called the adrenal gland. And specifically, the medulla. And the adrenal gland is an endocrine gland. So of course, it secretes its secretion, which is a hormone, into the blood. And in the sympathetic system, it's secreting norepinephrine into the blood. So the sympathetic system can act on the body as a whole, systemically, through utilizing norepinephrine as a hormone, or it can stimulate an organ directly through a neuron. Okay, so this is basically the setup of the autonomic nervous system. So this area here is the ANS, the autonomic nervous system. So in the next video, we're going to talk about exactly how where those two come from and how they work.